This lab is called Build Your Own Electric Motor, and clearly you're not going to be doing that. We're going to build it for you and then try and measure some of the capabilities it's got and try to understand its inner workings as we go through, so we make it go through some paces. This is what the final device is going to look like. More or less like what you see in your manual, but the coil design is a little bit different. We have this thing called a rotor in the middle that we wire around. We'll show you that in a minute. Between two sets of magnets, and we pass a current through it. And by passing a current through this coil and having it feel the Lorentz force from the magnets, we actually put a downward force on one of these coils when, say, it's in that position to cause it to rotate. And the motor is set up in a magic way so that when it rotates a little bit, the direction of the current changes when it gets to the other side. And then the force is, if it feels a downward force on this side, it feels an upward force on the other side. To do that, we start off with a naked rotor made out of a piece of wood. We grab some wire and we very laboriously put together the wire. The first thing we need to do is put together a bunch of loops in accordion style, as the lab manual says, to make the commutator that the current will pass to from these brass brushes onto the rotor. Then we want to make that nice and flat. And we will get a piece of tape that allows us to hold it in place on here. You can get it in about the right spot. Like that. There are my scissors. And then we wind the wire around like this, keeping track of what direction it's going. And then eventually we'll cross over and wind on the other side. We're not going to bore you with going through all of that, but that shows you roughly what you want to do, and there's some tricks you can do about exactly where you put the wires that are going to make contact with the brushes. The main trick is to make sure you round in the same direction on both sides, and then make another commutator on the other side with the remaining part of the wire. Once you've done that, you end up with a rotor that looks something like this. So I have wires going around on both sides, and I've got this set of wires here that I can make contact with. I take a razor blade and I scrape off some of the insulation from each of those so I can actually make electrical contact. Okay. Then I have to take my rotor and install it in the motor like this. So we have these little needles that act as bearings or bushings. I make connections with my brushes. And now one of the things the manual asks us to do is figure out what direction the magnetic field is. First, we do that by looking at how the motor behaves. So let's take a look at the motor closely. I'll line it up so you can see. So if you look carefully here, you see that these wires are connected to here. So on this side, the current's actually coming in this direction because this side is connected to the negative side. Remember, the current flows from the positive to the negative side of the battery. So here, this is the negative side, so the current's coming down the wire this way. So if we look at it from this direction, current is coming down. Now, if we look over here, if the current is coming down and the field is to the right-hand rule tells us the force would be out of the board, and that would mean that we have the thing kicked up and to the right. I'd be rotating clockwise. If the field was going the other way and I have the current going down, the force would be into the board, it would be down, and I would be rotating counterclockwise. So now let's take a look at what happens here. If I take a look from this orientation, I'm going to set it up there, have the switch closed, turn on the power supply, where it's set at 16 volts, roughly. And we put the current limit up to a number greater than what it wants. And then as soon as I hit the output, this should start to turn. It looks like it's going this way. So when it's in this position, the force is up. So that tells me the field is coming away from this guy. So I predict from that measurement that this pole has a north face on it. So I can check that. Okay, so let's take a look at this. So this side of that should be a north face. If I put this next to a compass, what part of the compass needle would point toward this north pole magnet? Well, on this compass, it's the silver side that points toward this. So which side is the silver? Does that point toward a north pole or a south pole? How would I figure that out? Okay, so here we are now outside of Swain. It's 2 in the afternoon, so the sun is somewhere over there. I'm sitting in the shadow of Swain, so I know that I'm in the northern hemisphere, so south is somewhere off in that direction. North's off in that direction somewhere. And here's my compass, and we see that the blue side of the needle is pointing to geographic north. That's what we call the north side of this little magnet that makes up the compass. Of course, the complication is that the geometric north pole has a south magnetic pole because the north pole of the magnet is attracted to it. So that north pole that I said was in the magnet in there, which attracted the silver side of the magnet, is in fact a north magnetic pole. Okay, so now that we've confirmed that this is a north pole, I'm going to put it there, and we'll just confirm that I've got the thing set up right. This side should be a south magnetic pole. So I bring it over here, and yes, lo and behold, it attracts that blue side of the compass needle. So yes, I have a north, looking at it from the viewpoint of the commutator, I have a north pole on the left side and a south pole on the right side, so the magnetic field is pointed from my left to my right, which is opposite for you because you're looking at it from the other direction, but from over here to over there. Okay? Now we're going to change the view of the camera and do a slow motion shot of the thing rotating so you can see for sure what direction it's moving. So we're going to hook it up here to a little pulley system that will allow us to lift some weights. So I have to get out of here, hook it up to the harness with a rubber band, and then we put the rubber band around this pulley. Oops. Should be simpler than I'm making it. There we go. Okay, so now we have our motor hooked up to its pulley system. We're about 36 centimeters, and we're going to start it with 16 volts of power. Now, another thing that's in the manual is the question of how might you change the direction of rotation of the motor. What we see here is if I reverse the direction of the current in a given position, then I reverse the direction of the force. That's probably the simplest way to do it. Let's come over here and see what happens. Now, we were rotating this way with the negative black lead on this side and the positive lead on that side. Let's swap those two around, trying to make sure that I don't let the leads get in the way of anything. And then we'll turn on the power. That looked to me like it went the other direction. And in fact, you can see that it's winding up this way. Now, how else might I change the direction? We'll let you guys think about that and make some predictions and have fun with it. We won't bother doing another demonstration.